In this video, we're going to talk about approximating the integration of a function using the midpoint rule, trapezoidal rule, Simpson's rule. We'll talk about how to solve some word problems too, and in addition, how to find or how to solve problems dealing with the error bound of the trapezoidal rule and the Simpson's rule. So let's go ahead and begin. Now let's say if we wish to calculate the area of the function x squared from 0 to 8. We know that the area is basically the integral from 0 to 8 x squared dx. Now let's get the exact answer using this process. For some problems, you won't be able to integrate the function. At best, all you can do is approximate the integration. And in those cases, the trapezoidal rule, the Simpson's rule, the midpoint rule might be helpful if you can't integrate the function or if you just have a data table. But let's go ahead and integrate this and see how we can approximate its value. The antiderivative of x squared is x cubed divided by 3, evaluated from 0 to 8. Now, if we plug in 8, it's going to be 8 cubed over 3 minus 0 cubed over 3. 8 to the third is basically 512. So the exact answer is 512 divided by 3. As a decimal value, that's about 170.67. So this is the exact answer. Now let's see if we can approximate this answer, starting with the midpoint rule. To find the area using the midpoint rule, we're basically going to use rectangles for the most part. So here's the graph of x squared, at least the right side of it. And if we draw rectangles, we can use it to approximate the area under the curve. Delta x represents the width of the rectangle, and f of x represents the height of the rectangle. So the area of the rectangle is basically delta x times f of x. And if you find the area of each rectangle, you can approximate the area under the curve. So the midpoint rule can help you to do just that. So it's going to be delta x times the sum of all of the heights of the rectangles that are in the interval. That is, in the interval from 0 to 8. A is 0, B is 8. Delta x, which is the width of the interval, is the difference between B and A divided by n. Now let's choose an n value of 4. Which means that we're going to use 4 rectangles to approximate the area under the curve. So delta x is going to be 8 minus 0 divided by 4, which is equal to 2. Now let's draw a number line. So the interval is from 0 to 8. And the width of each interval varies by 2. So these are the points of interest, 0, 2, 4, 6, and 8. Now for the midpoint rule to work, we're not going to use 0 or 2. We're going to use the value in between. That's 1, 3, 5, and 7. So for the midpoint rule, the number of values that we're going to use is equal to n. If n is 4, we're going to have 4 values, 1, 3, 5, and 7. So now let's estimate the integration using the midpoint rule. So m stands for the midpoint, and the subscript 4 tells us that the n value is 4. Delta x is the width of the interval, which is 2. And then we're going to find the y values at these 4 different x values. So that's f of 1 plus f of 3 plus f of 5 plus f of 7. And keep in mind, f of x is equal to x squared. So f of 1 is 1 squared, which is 1. F of 3 is 3 squared, that's 9. 5 squared is 25. 7 squared is 49. So 1 plus 9 plus 25 plus 49 is about 84. So this is equal to 2 times 84, which is 168. As we can see, 168 is not too far away from 170.67. So it's a fairly good approximation of the actual integration value. But now let's estimate the answer using the trapezoidal rule. So the equation for the trapezoidal rule, it's t sub n is equal to delta x, which is still b minus a divided by n. So it's delta x divided by 2, and times f of x0 plus 2f of x1 plus 2f of x2, and so forth. And then the second to last term will be 2 times f of x n minus 1. And then the very last term is going to be just f of x of n. So for the trapezoidal rule, the first term and the last term doesn't have a 2 in front. It has a 1 in front of it. Every term in the middle has a 2 as a coefficient. So that's what you need to keep in mind. As you can see, it has the shape of a trapezoid. Only the middle portion has a higher value, so we have a 2 for the middle part. So let's calculate t of 4. Now let's redraw the number line, because you need to know which points to choose. For the trapezoidal rule to work, given that n is 4, you're not going to use 4 points like the midpoint rule. Instead, you need to use 5 points. All 5 points, 0, 2, 4, 6, and 8. So if n is 8, you're going to use 9 points. Now delta x, which is the width of the interval, it's still 2. So it's 2 over 2. And then f of x0. The first point is an x value of 0. So that's f of 0. And then the next one, the x value is 2. But it's going to be 2 times f of 2 plus 2 times f of 4 plus 2 times f of 6, and then the very last term is just going to be f of 8. That's the way it works. Now let's make some space. Let's get rid of this stuff. So t of 4 is going to equal 2 divided by 2, which is simply 1, times f of 0. 0 squared is 0. And then 2 times f of 2. 2 squared is 4. Plus 2 times f of 4. 4 squared, 4 times 4 is 16. Plus 2 times f of 6. 6 squared is 36. And then plus f of 8. 8 times 8 is 64. So now let's add the terms that we have. Well, actually, first let's do some further simplification. 2 times 4 is 8. 2 times 16 is 32. 2 times 36 is 72. And let's add 64 to it. So 8 plus 32 plus 72 plus 64 is about 176, which is not too far away from 170.67. So this is still a good approximation. So that's how you can apply the trapezoidal rule to find the area under the curve or to approximate the integration value. Now the next one we're going to go over is the Simpson's rule. So here's the formula. S of n is equal to delta x divided by 3 times f of x0 plus 4 f of x1 plus 2 f of x of 2 plus 4 f of x n minus 1. That's the second to last term. And the last term is just going to be f of xn. So the first and last term has a coefficient of 1. That's what we need to know. The second term and the second to last term is going to be 4. And after the first term that has a 4, it's going to be 2, 4, 2, 4, 2, 4. And then after the second to last term, then the last one is just going to have a coefficient of 1. So the middle terms will alternate between 4 and 2. But the second term and the second to last term has to have a coefficient of 4. That's what you need to keep in mind. So now, let's draw the number line. Like the trapezoidal rule, in the Simpson's rule, you're going to use all 5 points, given that n is 4. So if n is 8, you're going to use all 9 points. You won't have to choose any other point other than what you see here. Delta x is still equal to 2, but this time it's divided by 3. The first point is f of 0, then it's going to be 4 times f of 2, and then after that it's 2 times f of 4 plus 4 times f of 6, and the last one is just going to be f of 8. So let's get the answer. So that's 2/3 times f of 0, which is 0 squared, that's 0, plus 4 times f of 2, 2 squared is 4, and then plus 2 times f of 4, 4 squared is 16, and then 4 times f of 6, 6 squared is 36, and f of 8 is 8 squared, which is 64. 4 times 4 is 16, 2 times 16 is 32, and 4 times 36, that's 72 times 2, which is 144. And then let's add 64 to it. So 16 plus 32 plus 144 plus 64, that's 256. 2/3 of 256 gives us 170.67, which is the actual answer. So just for this problem, the Simpson's rule worked pretty well in this example. So now let's try another example. Let's say f of x is equal to x cubed, and we wish to find the value of this particular integral from, let's say, 1 to 9. Follow the same process that we did earlier. Find the exact value of this answer and approximate the integral using the midpoint rule, the trapezoidal rule, and the Simpson's rule. Feel free to pause the video as you work on this example. Go ahead and try it. So first, let's find the exact answer. The antiderivative of x cubed is x to the 4th divided by 4, evaluated from 1 to 9. So this is going to be equal to 9 to the 4th divided by 4 minus 1 to the 4th over 4. Now 9 to the 4th power is 6,561 minus 1/4. So that's going to be equal to 6,560 divided by 4, which is about 1640. So this is the exact answer. This is what we want to approximate. So let's start with the midpoint rule in the interval 1 to 9. And this time, let's use 8 rectangles instead of 4, so we can get a better approximation of our answer. So let's begin by drawing a number line, starting from 1 to 9. Delta x is equal to b minus a, 9 minus 1 divided by 8, which is 8 over 8, that's 1. So the width of each interval is 1. So using the midpoint rule, we're going to use 1.5, 2.5, 3.5, 4.5, 5.5, 6.5, 7.5, 8.5. So for the midpoint rule, n is equal to 8, and we're going to choose 8 points. So let's begin. M of 8 is equal to delta x, which is 1, times the sum of all the y values. So that's going to be f of 1.5 plus f of 2.5 plus f of 3.5 plus all the way up to the last one, f of 8.5. So 1.5 to the third power, that is equal to 3.375. 2.5 to the third power is 15.625. And then 3.5 to the third power, that's 42.875. 4.5 to the third power is 91.125. 5.5 to the third power is equal to 166.375. And then 6.5 to the third power, that's 274.625. And then 7.5 raised to the third power is 421.875. And finally, 8.5 to the third power. That's about 614.125. So let's add up these 8 values. So this is equal to 1630. And if I remember correctly, the last answer was 1640. But let me just make sure. And yes, it was. So as you can see, this is still a very good approximation. 1630 is very close to 1640. But now let's approximate the answer using the Trapezoidal Rule. So if we redraw the number line, starting from 1 to 9, it's important to understand that even though I skipped 6, even though n is 8, you're going to use 9 points. All 9 points that you see on this number line. So for the Trapezoidal Rule and the Simpson Rule, you're going to use 1, 2, 3, 4, 5, 6, 7, 8, 9. So now that we know that, let's write the formula for the Trapezoidal Rule. It's going to be T9, which is equal to delta x. Delta x is 1 divided by 2 times f of 1, that's the first point, and then 2 times f of 2 plus 2 times f of 3. And then the second to last term will be 2 times f of 8. And then the very last term will simply be f of 9. So f of 1, 1 to the third power is simply 1. And f of 2, 2 to the third power, that's 2 times 2 times 2, that's 8. F of 3, 3 to the third power is 27. 4 to the third power is 64. 5 to the third power is 125. 6 to the third power is 216. 7 to the third power is 343. and 8 to the third power. I believe that's 512. And for the last one, it's going to be 1 times 9 to the third power, which is 729. Now let's simplify our result. So this is equal to 1/2 times 1 plus 2 times 8 is 16, and 2 times 27, that's 54. 2 times 64 is 128. 2 times 125 is 250. And 2 times 216, that's 432. 2 times 343, that's 648. And 2 times 512, that's 1024. And then plus 729. Now let's add up the values in the middle. So 1 plus 16 plus 54 plus 128 plus 250 plus 432 plus 648 plus 1024 and then plus 729. So that's about 3,282. So 1/2 of that is 1641, which is even closer to 1640. So in this case, the trapezoidal rule is very accurate. And basically all these methods are accurate. As long as you increase the value of n, the midpoint rule will be very close to the antiderivative of f of x dx in the interval a to b. And the same is true for the trapezoidal rule. As you increase n, it's going to be a better approximation of the integral. Now let's go over the Simpson's rule. Let's see what answer that is going to give us. So we're going to find s of 8, which is delta x, which is 1, divided by 3. And then the first point is going to be f of 1 plus 4 times f of 2. And then we're going to alternate between 4 and 2. The next one's going to be 2 times f of 3. And then 4 times f of 4. Plus 2 times f of 5. Plus 4 times f of 6. Plus 2 times f of 7. And 4 times f of 8. And then the last one is just f of 9. So that's the Simpson's rule. 1 to the third is 1. 2 to the third is 8. We know f of 3. 3 to the third is going to be 27. 4 to the third is 64. 5 to the third is 125. And then 4 times f of 6. F of 6 is going to be 6 to the third, which is 216. 7 to the third is 343. And then 4 times 8 to the third. 8 to the third is 512. And 9 to the third, we know it's 729. So 4 times 8 is 32. 2 times 27 is 54. 4 times 64, that's 256. 2 times 125 is 250. And 4 times 216 is 864. 2 times 343, that's 686. And 4 times 512 is 2048 plus 729. So now let's add the numbers in the middle. 1 plus 32 plus 54 plus 256 plus 250 plus 864 plus 686 plus 2048 plus 729. If I typed it in correctly, this is what I got, 4920. So let's divide that number by 3. And this gives you exactly 1640, which is very, very good. So as you can see, the Simpson's rule and the Trapezoidal rule, they're very good techniques in approximating the area under the curve, or the value of the integration. The volume flow rate of water leaving a tank in gallons per minute is shown in the data table below. Estimate the total volume of water that flowed out of the tank in the first 30 minutes using the Trapezoidal rule, Simpson's rule, and the Midpoint rule. So take a minute, pause the video, and work on this example. Now the first thing we need to know is the value of n. What is n equal to in this problem? Now notice that there's 7 points, which means that n is 6. So we need to calculate the width of each interval, which you probably could already see it. Notice that the time changes every 5 minutes in the table, so delta x should be 5. A is 0, b is 30. So delta x is b minus a divided by n. So that's a 30 minus 0 divided by 6, which is 5. That's the width of each interval. So now that we have that, we can go ahead and begin to solve this thing. So let's calculate t of n, or t of 6, since n is 6. This is going to be delta x, which we know to be 5, divided by 2, times f of 0 plus 2 times f of 1, which in this case is really f of 5, plus 2 times f of 10, plus 2 times the second to last term, f of 25, and then the last one, which is just f of 30. 5 over 2 is about 2.5. f of 0, the rate of change when t is 0 is 12.3. And then it's going to be plus 2 times the y value at t equals 5, which is 12.7. And then it's 2 times 13.1, and then 2 times 13.3, plus 2 times 13.4, plus 2 times 13.2, and finally plus 13.1. So now let's simplify our result. So we have 12.3 plus 2 times 12.7, which is about 25.4. 2 times 13.1, that's 26.2. The next one is going to be 26.6, and then 26.8, and then 26.4 plus 13.1. So 12.3 plus 25.4 plus 26.2 plus 26.6 plus 26.8 plus 26.4 plus 13.1. What I got is 156.8. And then let's multiply that by 2.5. So according to the Trapezoidal rule, in the first 30 minutes, 392 gallons of water will exit out of the tank. Now let's try the Simpson's rule. So let's calculate s of 6. So it's delta x divided by 3, so that's 5 divided by 3, plus f of 0 plus 4 of f of 5 plus 2 times f of 10 plus 4 times f of 15, and then 2 times f of 20, 4 times f of 25, and then finally just f of 30. So that's it for the Simpson's rule. Now let's go ahead and plug in these values. So as you can see, it's going to alternate between 4 and 2 in the middle. And the first and last term will have a coefficient of 1. So we know f of 0 is just 12.3. And f of 5 is 12.7, but multiplied by 4. And then f of 10, that's going to be 2 times 13.1, and then 4 times 13.3, and then 2 times 13.4, plus 4 times 13.2, and finally plus 13.1. Four times 12.7 is 50.8. 2 times 13.1 is 26.2. 4 times 13.3 is 53.2. 2 times 13.4 is 26.8. And 4 times 13.2 is 52.8. And finally, plus 13.1. So let's add the terms inside the brackets. 12.3 plus 50.8 plus the other values is 235.2. Now let's multiply it by 5 and then divide it by 3. So this gives you the same answer, which is 392. Now what about the midpoint rule? How can we apply it in this particular problem? Now for the Simpson's rule and the Trapezoidal rule, we use an n value of 6, but for the midpoint rule, we need to choose an n value of half of that result, which is 3. If n is 3, delta x is going to be b minus a, which is 30, divided by 3, and that's going to be 10. So this is going to be 0, 10, 20, and 30. Now the midpoint between 0 and 10 is 5. So we're going to use this value. And the midpoint between 10 and 20 is 15. So we're going to use this value. And the midpoint between 20 and 30 is 25. We can't choose an n value of 6 because we don't know what the midpoint between 0 and 5 is. We can say it's an average of 12.5, but we really don't know what v prime is at 2.5. So we have to choose an n value that's half of what it was for the Simpson's rule and the Trapezoidal rule. So this problem should be shorter. So M3 is going to be delta x, which is 10, times f of 5 plus f of 15 plus f of 25. So at 5, the rate is 12.7, and at 15 it's 13.3, and at 25 it's 13.2. So 12.7 plus 13.3 plus 13.2 is 39.2, and 10 times 39.2 is 392. So this is pretty rare when the midpoint rule, the Simpson rule, and the Trapezoidal rule all give you the same answer. So it's safe to say that 392 gallons of water leaves the tank in the first 30 minutes. Given the speed of a runner in the data table below, use the midpoint rule and the Trapezoidal rule to estimate the distance in meters traveled by the runner in the first 32 seconds. So let's start with the midpoint rule. Let's make a number line. Now for the Trapezoidal rule, notice that there's 9 points, so that the n value should be 8. But for the midpoint rule, we have to use half of this particular n value. We need to use 4. Now the data table goes from 0 to 32. And our points of interest are 16, 8, and 24. So we're going to use an n value of 4 for the midpoint rule. So if we calculate delta x, it's b minus a, 32 minus 0, divided by 4. So for the midpoint rule, the width of each interval is 8, which is what we have, starting from 0 to 32. Now we need to use the middle values. That's 4, 12, 20, and 28. So therefore, the value of the integral from 0 to 32 v of t dt is approximately equal to m of 4, which is equal to delta x. Delta x is 8 times f of 4 plus f of 12 plus f of 20 plus f of 28. So f of 4, when t is 4, v is 5.6. F of 12 is 8.3. F of 20, 9.4. And f of 28 is 8.6. Now let's add the 4 values in the brackets. So 5.6 plus 8.3 plus 9.4 plus 8.6, that is equal to 31.9. So this is 8 times 31.9, which is 255.2. So this is 255.2 meters. That's how far he's going to run in the first 32 seconds. Now let's estimate the answer using the trapezoidal rule. So this time n is going to be equal to 8. So we're looking for t of 8. Delta x is going to be b minus a, which is 32 divided by 8. So delta x is 4. Now according to the trapezoidal rule, is delta x divided by 2 times f of 0 plus 2f of 4. For the trapezoidal rule, we're going to use all of the points. N is 8, but we're going to use all 9 points that we see on the graph. And then this is going to be 2 times f of 8 plus 2 times f of 12. And then 2 times f of 28. And finally, f of 32. Four divided by 2 is equal to 2. F of 0 is 0. F of 4 is 5.6. F of 8 is 7.2. And then it's going to be 2 times f of 12, which is 8.3, plus 2 times 9.1, and then 2 times 9.4, plus 2 times 9, plus 2 times 8.6, and then plus f of 32, which is just 7.5. So 2 times 5.6 is 11.2, and 2 times 7.2 is 14.4. 2 times 8.3, that's 16.6. 9.1 times 2 is 18.2, and 9.4 times 2 is 18.8, plus 2 times 9, which is 18, and then 2 times 8.6, that's 17.2, and then plus 7.5. 11.2 plus 14.4 plus 16.6 plus 18.2 plus 18.8 plus 18 plus 17.2 plus 7.5. This is about 121.9. Multiplied by 2, this is 243.8, which is not too far away from the other answer. So this is the estimation using the trapezoidal rule. How large should we take n in order to guarantee that the midpoint rule approximations for the integral shown below is accurate within 0.0001? So what's the formula for this type of problem? Well, the error associated with the midpoint rule is less than or equal to k times b minus a raised to the third power divided by 24n squared. So E represents the error. K is the value that it's the maximum value of the second derivative. So here's the second derivative. The absolute value of the second derivative is less than or equal to k. So k is the maximum value of the absolute value of the second derivative. A and b are basically the numbers in the interval. A is 1, b is 4. So in this problem, we need to solve for n. The error is 0.0001. So let's rearrange the equation. To do that, you can just simply switch these two. So n squared is less than or equal to k times b minus a raised to the third power divided by 24 e to the m. Now let's begin by writing down what we know. So we know that a is equal to 1, b is equal to 4, and em, the error associated with the midpoint approximation, is 0.0001. The only thing we're missing is the value of k. So we need to find the second derivative. F of x is equal to 1 over x, which is the same as x to the minus 1. So the first derivative, using the power rule, is going to be negative 1x to the minus 2. The second derivative is going to be negative 1 times negative 2x to the minus 3, which is equivalent to 2 divided by x to the minus 3. If you plot the graph 2 over x cubed, the right side of the function looks like this. It's a decreasing function. So that tells us that the maximum value of this function is basically going to occur at the a value of 1. If it's an increasing function, the maximum value will occur at the b value. But if you're ever unsure, plug in both. So what is f double prime of 1 and f double prime of 4? Since this function is always decreasing, the right answer is going to be at the endpoint, either at 1 or 4. If we plug in 1, 2 over 1 cubed is 2. If we plug in 4, 2 over 4 cubed, that's 2 over 64, which is 1 over 32. So the maximum value in this interval is 2. So k is equal to 2. So let's plug in the data. N squared is going to be less than or equal to k, which is 2, times b minus a, that's 4 minus 1, raised to the third power, divided by 24 times em, which is 0.0001. 4 minus 1 is 3, and 3 to the third power is 27. 24 times 0.0001 is 0.0024. 2 times 27 is 54, divided by 0.0024. This tells us that n squared is less than or equal to 22,500. So to calculate n, we need to take the square root of both sides. So n is equal to 150. So therefore, we want to choose an n value of 150 in order to get an answer that is accurate to 0.0001. Now, there are some more formulas that you need to know. For the trapezoidal rule, the maximum value of the second derivative is less than or equal to k, very similar to the midpoint rule. And x is between a and b. That is, it's in the interval a to b. So the error for the trapezoidal rule is equal to, or it's less than or equal to, k b minus a to the third power divided by 12n squared as opposed to 24n squared in the case of the midpoint rule. Now what about Simpson's rule? What's the error equation for that? So for the Simpson's rule, the maximum value of the fourth derivative is less than or equal to k in the interval a to b. And the equation is this: the error is less than or equal to k times b minus a, but to the fifth power instead of the third power, divided by 180 n to the fourth. So here is the last problem for today. Approximate the integrals shown below using the trapezoidal rule using n equals 4. So let's start with that part first. So if we make a number line, it ranges from 1 to 2. And let's calculate delta x, which is b minus a, 2 minus 1, divided by n. So it's 1/4. So the 5 points of interest are 1.25, 1.5, and 1.75. As you can see, delta x is 1/4, or 0.25, which is the width of each of these intervals. So now let's calculate t of 4. It's going to be delta x, which is 0.25, divided by 2, times f of 1, plus 2 times the value of f of 1.25, plus 2 times f of 1.5, plus 2 times f of 1.75, and finally, plus f of 2. 0.25 divided by 2 is 0.125. F of 1 to the third power is 1. And 1.25 to the third power is about 125 divided by 64. 1.5 to the third power is 27 over 8. 1.75 to the third power is 343 divided by 64. And 2 to the third power is equal to 8. If you type this in your calculator, you should get 3.796875. So this is equal to T4. Now let's calculate the error associated with this value. So we can see that A is equal to 1, B is equal to 2, N is 4. All we need to find is K. Now f of x is x cubed. F prime of x, the first derivative, is 3x squared. The second derivative is 6x. Now 6x is an increasing function, so f prime of b is going to give us the maximum value. But let's find both. F double prime of 1 is 6. F double prime of 2, that's 6 times 2 is 12. So that's the largest value in the interval. Therefore, k is equal to 12. So now let's find the error associated with the trapezoidal rule. So it's going to be less than or equal to k times b minus a to the third power divided by 12n squared. So k is 12, b is 2, a is 1, divided by 12 times n squared, or 4 squared. 12 divided by 12 is 1, so those cancel. 2 minus 1 is 1, 1 to the third power is 1, and 4 squared is 16. Now, 1 divided by 16 as a decimal is 0.0625. So we can say that the actual answer should be somewhere between 3.796875 plus or minus 0.0625. .796875 minus 0.0625 is about 3.734375 on the low side. And if we add the two values, it's about 3.859375 on the high side. So let's see if the actual answer is within this range. Now let's evaluate the integral from 1 to 2. The antiderivative of x cubed is x to the 4th divided by 4. If we plug in 2, this is going to be 2 to the 4th divided by 4 minus 1 to the 4th divided by 4. 2 times 2 times 2 times 2 4 times is 16. 1 to the 4th is just 1. And 16 minus 1 is 15. Now 15 divided by 4 as a decimal is about 3.75. So this is the exact answer. And notice that the exact answer is indeed within the range. It's between 3.73 and 3.859.